For part D, oh, nope, sorry, part E, if I can remember where we're at, things actually get a little bit more interesting here. Hopefully they've gotten boring on the first few. That's my goal. Once you catch on to what the construction theorem says, it gets really boring to take derivatives of antiderivatives that we built with the construction theorem. But here, there's a tiny bit of a twist. We were very deliberate in building our area functions, our construction theorem functions, so that they started from some fixed x-coordinate and they stopped at some variable x-coordinate that we got to determine. And this one is backwards. It's starting at some variable point and it's ending at a fixed point. So this doesn't drastically change it, but it does change it a little, and there's two ways to think about this. One is we can get back to what we're expecting to see with the construction theorem just by using one of our properties of integrals that says changing the limits of integration just changes the sign of your answer. And at that point, we can say, okay, multiplying by a -1, that just carries through when you take a derivative, so you can kind of mentally move that out in front and say the -1's just going to sit there. When I take the derivative of the antiderivative of 5 to the negative x cubed plus 2, I'm going to get back to that same function, only we've switched variables along the way. You can actually sort of mentally walk yourself through this one step by step as well, but we'd have to do something where we'd say, okay, when we find the antiderivative, let's just call it big F of x. So I'm just saying in the usual sense, I would look at 5 to the negative x cubed plus 2. I find an antiderivative for that. The antiderivative, it doesn't matter because this is going to be a definite integral, so I find an antiderivative. I would then, so the derivative is still hanging out in front, I haven't touched it. I would then evaluate whatever this function is at t and at -3. And the deal here is that that function's complicated enough that I don't know the formula for big F, but I can still walk through what would happen. So I would plug -3 in, and then I would plug t in, and I would subtract, and the derivative of f of -3 is 0. The negative here is going to come along for the ride. The derivative of big F of t is 5 to the negative t cubed plus 2. So same idea, negative sign comes out either way. We have to do something if those are in the wrong order. Okay, so for part F, the little bit of a twist in part F is we are building an area function. We have the integral from 5 to variable of sine of 1 over w dw, but the variable actually has something done to it. So this isn't just the integral from 5 to z, which would make it actually the basic area function. This is our area function with the square root of z plugged into it. So this is actually a composition. So the way this would work is we'd say, okay, side note up here up above, I know how to take the derivative of a composition. I take the derivative of the outer function, I leave the inner function alone, and then I chain out the derivative of the inner function. The outer function here is the area function, so its derivative is just going to get us back to this sine of 1 over w, but it's not going to be a w anymore, it's going to be a square root of z. And then the inner function is that square root of z, so its derivative is 1 over 2 root z, or 1/2 z to the negative 1/2. Okay, so if you want to walk through that one the longer way, we could say, okay, let's say that we find the antiderivative of this function. Since I don't know what it is, I'm going to call it big F of w. We would say, well, I need to take the derivative of this big F of w, and then I need to evaluate it at 5 and root z, and then I'll take the, I think I said that in the wrong order. I find the antiderivative of big F of w, I evaluate it at 5 and root z, and then I take the derivative. So derivative still hanging out in front. There's my evaluate. When I take the derivative, I'm going to think in backwards order here. When I take the derivative of f of 5, I'm going to get 0 because that's constant. When I take the derivative of big F of z, I get back to my little f, which is sine of 1 over, and it's going to be 1 over root z because that's what I'm plugging in. And then again, the chain rule says if you want to take the derivative of f of the square root of z, you're going to get big F prime of the square root of z multiplied by the derivative of the square root of z. So I'm going to get sine of 1 over w evaluated at square root of z multiplied by the derivative of the square root of z, which again is just a power rule. So there can be chain rules tied into some of these, and this is really just getting you to pay extra attention and remember some chain rule stuff. Again, the point is that when you take the derivative of the antiderivative of sine of 1 over w, you get back to sine of 1 over w. Pay attention to variables, pay attention to composition.